So let's turn our attention to a new topic, which is thinking a little bit about the periodic table and also talking about periodic trends. And there's a lot we can explain by talking about what we see in the periodic table in terms of what different trends are and grouping different elements in different spots within the periodic table. So here we have a picture of Dmitry Mendeleev, who is one of the scientists responsible for first compiling the periodic table. You'll notice I have what's a very flattering picture of him up here. And if you haven't done the reading yet, you might not think this is particularly flattering, but if you look at the picture of him in the book, you'll notice I chose a very, very flattering picture of Dmitry up here. And here he's pondering putting these elements together in a periodic table. And he actually did this in the late 1800s, back before even all of the elements that we know today were discovered. Really, only about 60% or so, 70% were discovered then that we now know today. But still, he was able to put together a periodic table. And what he did was he actually grouped things in terms of their chemical properties. So the way that we like to think of things now is in terms of electron configurations, right? But at the time, that wasn't really understood. So instead, it was amazing he was able to group things in terms of the properties that he saw. So for example, if he was talking about the group 1 metals, lithium, sodium, potassium, he noticed these were all very soft reactive metals. Those were grouped together versus looking at, for example, helium or neon or argon. These are all inert gases, inert meaning essentially do not react. Those were grouped together in the periodic table. So basically, at the time, he was just going on size and then traits. But what we actually know today is that we can also order things in the periodic table by electron configuration. In fact, that is the most logical way for us to look at it now. So for example, if we're actually thinking about electron configuration and we look at lithium, sodium, and potassium, these all have one valence electron. So basically that means one electron in an s orbital in their outermost shell. So that explains why they're so reactive. They're all very willing to give up that one s orbital and then drop to a lower energy level. In contrast, helium, neon, and argon all have filled shells. That also explains why they're very stable. They're not going to want to add on another electron because then they'll have to jump a very large energy level and start filling in another shell, go from n equals 2 to n equals 3, n equals 3 to n equals 4, and so on.